Hello and welcome. This video is part 2 of our 5-part basic skills mathematics review, and in this video we're going to cover decimals and percents. As an important note, throughout the video please have paper and pencil ready, and this goes for all the videos that I provide for you. And make a real effort to work out all the examples on your own before viewing the answers. And always remember, mathematics is not a spectator sport. You do not learn mathematics by watching someone else do it or by reading it. You learn mathematics by doing mathematics. We will begin with decimal numbers. And as you know, not all numbers that we encounter describe whole quantities like 5, 6, etc. There are times we need to consider parts of wholes, like 5.5, 5 3/4, etc. For example, when is the last time you went to the grocery store and ended up paying a whole number of dollars? That is usually something most people consider to be extremely rare, and some, of course not most mathematicians, even consider it to be a sign of good luck. Most mathematicians, of course, consider it to be just a very random event. No other number plays as large a role when it comes to understanding decimal numbers than the number 10. That's because when a number is written in decimal notation, each digit represents a place value that is simultaneously 10 times larger than the place value of the digit to its right and 10 times smaller than the place value of the digit to its left. As a simple example, if we look at the number, say 356, right? Consider the number 5. We know it's in the tens position, right? Notice that it is the place value of 5 is 10 times larger than the digit to its right, as we said here, and it's 10 times smaller than the place value of the digit 3, which we know, of course, is in the hundreds position. That's exactly what we are talking about when we say this phrase. Sometimes, you read words, they don't make much sense. You look at an example, everything just starts to click. Consider this other simple example, 394.68. In this number, which is written in decimal notation, the decimal point is an important reference point. The place value of the first digit to the left of the decimal point, meaning the 4, is 1, as we know. The place value of the second digit to the left of the decimal point, that is the place value of 9, as we know, is 10, which is, of course, 10 times larger than the place value of 4. So its place value is obviously 10 times 1, which is 10. The place value of the third digit to the left of the decimal point, that is basically the place value of this 3 here, is going to be 10 times larger than the place value of the 9, so it'll be 100, etc. Now, the place value of the first digit to the right of the decimal point, meaning the place value of this 6, is going to be 10 times smaller than the place value of the 4. We know the place value of 4 was 1, so 1/10 is the place value of the 6. Again, you're going to go 10 times smaller again, and that gets you to what? 1/10 of 1/10, which is 100ths. All right, and so on and on and on and on and on. The same exact logic applies to decimal numbers containing any number of digits. So when you see a number like 394.68, your brain is doing a lot of processing at a lightning pace without you realizing it. The extended or expanded form of this number is, we're basically going to say 3 times 100 plus 9 times 10 plus 4 times 1 plus 6 times 1/10 plus 8 times 1 over 100. So this number has 3 hundreds in it, 9 tens, 4 ones, 6 tenths, and 8 hundredths. And of course, your brain is instantly comprehending all this information when you look at this number, so which is quite amazing. Now you try it. Go ahead and write this number in expanded form. Make sure you try it before you watch the rest of the video. Alright, so this is what you should have come up with. So we know that this is the ones, so that's the tens, hundreds, thousands, right? So this number has 5 thousands in it, 6 hundreds, 9 tens, 3 ones, 7 tenths, 5 hundredths, and 3 thousandths. Okay, and that's how you would write that in expanded form. So even with just the little we've learned, you should have a much better understanding of decimal numbers, as well as a greater appreciation for the enormous calculational capabilities of your brain. Read further to learn more about extremely important powers of 10. And of course, in the case of the video, watch further. Now we want to take a look at the powers of 10. Powers of 10 play an important role not only in the understanding of decimal numbers, but also in doing operations on decimal numbers. They also play a very important role in decimal percent conversions. So let's go ahead and remember that a power is a number written in the form like that, 10, and then an exponent of 3. So we know that each item in this expression has a name. The 10 is called the base, 3 is called the exponent, which some people incorrectly call the power. The power is actually the whole thing. We say it's the third power of 10. All right, so that would be the correct way of using the word power. To evaluate a power like 10 cubed, which is what we call a power when the exponent is 3, we need to use 10 as a factor in a product 3 times. So just like this. And when we multiply those, of course, we get 1000. More generally, the nth power of any number x is calculated by using x in a product as a factor n times. So x to the n is going to be x times x times x, on and on. How many times? N factors. And that's what we mean by x to the n, or the nth power of x. The nice thing about powers of 10 is that they're extremely simple to compute. Let's look at the first few positive powers of 10 to see if we can see a pattern. Notice 10 to the power of 1 is just, of course, 10. Or I should say the first power of 10 is just 10. The second power of 10 is, of course, 10 times 10, which is 100. The third power of 10, or 10 cubed, is going to be 10 times 10 times 10, which is 1,000. The fourth power of 10 will be 10,000. The fifth power will be 100,000. Notice the pattern. Basically, when you have a natural number power of 10, you're going to get a 1 followed by as many zeros as the exponent. See? 10 to the 4 is a 1 and 4 zeros. 10 cubed is a 1 and 3 zeros. 10 squared is a 1 and 2 zeros, etc. And to generalize, 10 to the n is going to be 1 followed by n zeros for any natural number n. So when we write 10 squared equals 100, we are seeing the second power of 10 in two different forms. The second power of 10 in exponential notation will be exactly that, 10 squared. and in standard notation it'll just be 100 that we're familiar with. Or to generalize, the nth power of 10 in exponential notation is just 10 to the n, and n can be any positive natural number. The nth power of 10 in standard notation is going to be 1 followed by n zeros, and here again n can be any positive natural number. Next we want to look at multiplying by powers of 10. The nice thing about powers of 10 is that multiplying by them is also very simple. To multiply by a power of 10, you're basically going to take the decimal point of the number that's being multiplied by the power of 10 and move it to the right as many places as there are zeros in the power of 10, as long as, of course, the power of 10 is written in standard form. For example, if you want to multiply 536.25 by 10,000, all we're going to do is we're going to take this decimal point here and we're going to move it 4 places to the right. So it was right after the 6, so you get 1, 2, 3, 4. But we noticed that we ran out of digits after we moved 2 places to the right. So what do we do then? We add zeros after we run out of digits until we have traveled the required number of places to the right. Of course, to the right of the original decimal point. So here's an example. Go ahead and try it and see what you think the outcome should be before you come back to the video. Alright, so I'm hoping that you came up with this, which of course is what you get when you take this original decimal point here. Notice no 0 was written on the left. That's okay. The 0 is optional. Alright. What we did was we took this decimal point and moved it 2 places to the right. Why? Because we were multiplying by 100. 100 is a power of 10 written in the standard notation, and it has 2 zeros in it. So that means we need to, when we multiply by it, we need to move the original decimal point of the number that's being multiplied by 100 2 places to the right. Try this one, then come back to the video. Alright, so this should be the outcome, and you may be wondering, what decimal point am I going to move? There's no decimal point in here. Remember, all whole numbers have decimal points in them. It's just if you don't see one, then it's at the very end on the right side, right? So basically, when you're going to multiply this whole number by 1,000, you're going to be adding 3 zeros at the very end is what's going to happen. So we have the 5600, and then we add 3 zeros at the end, and that's it. Now, if you multiply by a power of 10, which is written in exponential form, then what you're going to do is you're going to multiply the decimal point of the number that's being multiplied by that power of 10 as many places to the right as the exponent of the power of 10, which is written in exponential form. Here we have 536.21 times 10 to the 4. So that means we're going to take the decimal point here and we're going to move it 4 places to the right. So it was right after the 6, so we go 1, 2, 3, 4, and we end up with this number, because remember, we put zeros once we ran out of digits. Now, we saw this before, but we multiplied by 10 to the 4 in standard notation before, which was 10,000. So the result is, of course, going to be the same regardless of the form of the power of 10. Here's another problem we saw earlier, but again, we saw it with the 10 squared written in standard notation as 100. But here we do the same thing, but except, remember, you move 2 places because of that 2 right there. So you look at the exponent of the power of 10. and this was the last one that we saw. Again, before we saw this as 1,000, now we see this 10 cubed, same outcome. Now we want to take a look at dividing by powers of 10. Basically, dividing by powers of 10 is not really harder than multiplying, except that instead of moving that many places to the right of the decimal point, you're going to move to the left. That's as simple as it is. If the power of 10 is written in standard form, then you move to the left as many places as it has zeros in it. If it's written in exponential form, you move to the left as many places as the exponent of the power of 10 in exponential form. So here we can see we're going to take 536.25 and divide it by 10,000 this time. So that's going to take this decimal point here and move it to the left 1, 2, 3, and 4. So since we ran out of digits one place, we need to put 1 0 here, and that's where the new decimal point is going to be. So before we multiplied this by 100, now we're going to divide it by 100, and notice we get this decimal point moved to the left 2 places. Well, there's already nothing there, so we start adding zeros right away. So that's why we get 2 zeros and then a decimal point. Again, we multiplied this number by 1,000 before. Now we're going to divide it by 1,000, and of course that's going to move the decimal point of this original number that's being divided by the power of 10 3 places, this time to the left. So that's how you go from here 1, 2, 3. So the new decimal point is going to be after the 5. So that's why you get this. Now these 2 zeros don't really contribute anything, so we can just drop them and we'll write 5.6. The only time we would keep the zeros there is if we were dealing with significant digits and we wanted to show the level of precision for measurements. Otherwise, we would always simplify this as 5.6. Another way of thinking about dividing by powers of 10 is by thinking about it as multiplying by negative powers of 10. And that's a concept we'll get into later in the course. So it would just be confusing at this point. We're going to delay it for later. Now we want to take a look at the concept of percents. Percent literally means per 100. The symbol we use for percent is this familiar symbol right here. It's nice to visually view what we mean by percent. So if we take one whole and divide it into 100 equal parts, 25% would just be a shading of 25 of those 100 smaller squares. All right, and this is a notice the 25% you can see visually is also the same as 1 out of 4, right? So they're exactly equivalent. Here's a visual presentation of 50%. Of course, again, we take one whole, which is that large square, divided into 100 equally sized smaller squares. And of course, since we want 50 of the 100 represented here, we're going to shade 50. Notice that that actually turns out to be the same as 1/2, 1 out of 2, right? So here we can see 75%, so 75 of the smaller squares are shaded, and notice that's like 3/4, right? And of course 100%, that means all of them. So That's why 100% is the same as 1 whole. Now we can also deal with percentages higher than 100. So if we want to look at 200%, we're going to get 2 wholes, right? So this way we would have to shade 2 whole squares. We want to look at some conversions now from percent to decimal, and then we'll look at the other way as well. By definition, whenever you see a percent symbol, you can remove it and divide the number which was written to the left of the percent symbol by 100 to get the decimal equivalent of that percent. So here's some examples. 100%, we want to convert it to a decimal, so we're just going to take 100 divided by 100. We're just replacing the percent by a division by 100, and we get 1. 50%, so that's going to be 50 over 100, which is 0.5. 75%, that's 75 over 100, which is 0.75. 0.5%, for example, would be 0.5 over 100. We know that means we need to move the decimal 2 places to the left. That's where we end up with 0.005. 200% is 200 over 100, which is 2 wholes, right? So in other words, 100% of a given quantity is the same as 1 whole of that quantity. 50% of a given quantity is the same as 0.5 of that quantity. 100%, I repeated myself here for some reason, is the same as 1 whole of that quantity. 75% would be the same as 0.75 of that quantity. 0.5% would be 0.005 of that quantity, and 200% would be the same as 2 wholes of that quantity. For example, 50% of 300 is just going to be 0.5 times 300, which is 150. 0.5% of 300 is going to be 0.005 times 300, which is 1.5. When you see of in mathematics, think times, right? 200% of 300, that's just going to be 2 times 300, which is 600. It is also easy to convert percents to fractions because the first step is the same as the one used for converting the percent to a decimal. Namely, remove the percent sign and divide the number to the left of the percent sign by 100. Then, if the fraction obtained in this manner is already in lowest terms, we're finished. We've just converted the percent to a fraction. If the fraction obtained is not in lowest terms, we simply proceed to cross-cancel until we obtain a fraction in lowest terms. For example, 100% would be 100 over 100. That's not simplified. We simplify it and we get 1. 50% is 50 over 100. When we were converting to decimals, we would take this and write it in decimal form as 0.5. But now we want to leave it as a fraction, so we just reduce the fraction by dividing top and bottom by 50, and we get 1/2. 75% is the same as 75 over 100. We know that 25 goes into both of them, so we divide it off from both of them, and we end up with 3/4. 0.5%, that's like 0.5 over 100. Now, this is going to look a little bit different to you because we're multiplying by 10 out of the blue. Well, the reason we do that is because we're going to get rid of this decimal, so we get a nice simple fraction. And of course, as long as I multiply the top and the bottom by the same number, I'm really just multiplying by 1, which I can do with any number, right? Because that's the 1 is the multiplicative identity, right? Which we'll learn about very soon. So I end up with 0.5 times 10, which is 5 on the top, and 100 times 10, which is 1,000 on the bottom. And now I know 5 goes into both of those, so when I divide it off from both, I get 1 over 200. 200%, of course, is 200 over 100, which if we reduce, we just get 2, simply a whole number. When you deal with something like 17%, you write it as 17 over 100. That's it, you're done. There's no reduction possible. This is already in lowest terms. Now, if you want to convert either a decimal or a fraction to percent conversion, you're in luck, because that's the easy direction. The only problem to figure out here is how to introduce a percent symbol without changing the value of the original number, and that can easily be accomplished if you simply remember that 100% has the value of 1. So you also need to remember that multiplying any number by 1 doesn't really change the number. So this is one of the things we need to know, and we also need to know that n times 1 is n. Now let's see how we're going to use that to convert decimals and fractions to percents. So we take a number like 0.7, we want to convert it to a percent. We're going to first realize that we can write it as 0.7 times 1. We know that 1 is the same as 100%, and now we just multiply the 0.7 by 100, which gives us 70, and keep the percent. That's it. So basically, the simplest thing to understand is that if you want to convert either fractions or decimals to percent, just multiply by 100%. Why can you do that? Because that's just 1, and you can multiply any number you like by 1. All right, so we're going to convert 1.5 to percent. Remember, that's the easy direction. Just multiply by 100%. Of course, then we'll take care of this multiplication. 1.5 times 100, which gives us 150, and then the percent symbol remains. So 1.5 is the same as 150%. What does that mean? That means 1.5 of some quantity is the same thing as 150% of that quantity. How about converting 6 to percent? Well, remember, we're just going to take 6 and we're going to multiply it by 1, which can also be written as 100%. So we basically end up with 600%. Here we're going to convert 1/2 to percent, so we realize that we can just do that by multiplying by 1 or 100%, and we end up with 50%. Now to convert 3/4 to percent, we're going to do the same thing. Take 3/4, multiply it by 100%, so we end up with this quantity and then a percent. So we just reduce this. 4 goes into 125 times 3 is 75. So we end up with 75%. All right, so just to summarize what we've learned in this video, we've learned that decimals, fractions, and percents are all methods of expressing parts of wholes, right? We've also learned that it's possible to go from any of these 3 forms to any of the other forms. So 50% of 20, 0.5 of 20, or 1/2 of 20 all mean the same thing, and they all refer to the number 10. All of them are going to be equal to 10. Next, I want to leave you with some exercises to practice. So I'm going to stay on each screen for a few seconds and then move on to the next screen, and then at the end I will also present the screens for the answers. So if you want to copy these and work them 5 at a time, etc., that's up to you. Or if you want to just write them all down and work them out, again, completely up to you. This is optional. This is all review, so it's not a mandatory assignment, but it's highly recommended if you're not comfortable with this kind of thing. So here it goes. Now we're going to the next page. You can of course always pause the video and copy them down, etc. All right, going to the next page. All right, there's a few more. And here are the answers. But for your own sake, please try them on your own before you come to view the answers. All right, so that brings us to the end of this video. So please practice and stay safe until our next video.